Good afternoon, everyone. My name is David Nuñez. I'm a cryptographer at NuCypher. NuCypher is a US company. We provide cryptographic tools to enhance privacy for distributed applications. We basically, the main topic of the call will be our work on the proxy re-encryption-based tool, but we also have, our focus is to provide privacy-preserving solutions, and we also are targeting other ideas like fully homomorphic encryption and such. Okay, so this is the typical slide with really scary charts about data breaches, losing money, and everything, so I won't bore you with that. We all know that data protection of data is important, and it costs money. So what are we providing? What is NuCypher providing? NuCypher is providing a secure way of sharing data that is encrypted. So I don't know if you are familiar with encryption or public key encryption. I would assume that you are more or less familiar with it. And if you have at some moment try to use or share data that you have encrypted with your public key, for example, you will notice that it has several limitations. For example, in order to share data with someone, if your data has already been encrypted, it means you will have to decrypt it on your side. Or worse, another option is you will have to share your private key with some intermediate entity. This is something typical what we can do with Amazon or Google, where the data is stored in the clear in the server. So public key encryption doesn't allow to share data in a secure way. It's not scalable. Its revocation is very difficult. Of course, and there are many potential intermediate actors that can, spy on your data and everything. So what's our proposal? Our proposal is to use a type of crypto system called proxy encryption. So proxy encryption is a very cool crypto system that basically has the same feature of public key encryption, but extended with a new functionality called re-encryption. What re-encryption does, it basically allows a proxy entity, an intermediate entity, to transform a ciphertext that has Alice's public key and transform it to someone else's public key. So, for example, if I am Alice, I have tons of data that is already encrypted with my public key, and I want to share this data with Bob or with Charlie. What proxy encryption allows is for me to create a special key called the re-encryption key. The re-encryption key is generated using my private key and the public key of the recipient. So with this information, I create this re-encryption key, and I handle this key to a proxy. So the proxy now can take my ciphertext and transform it to ciphertext that can be opened by the recipient with their own private keys. The cool thing is that the proxy never learns any data, nor they learn any private key. That kind of data sharing functionality is impossible to do with any kind of traditional public key or symmetric key encryption. So we go one step further than this, because what I explained before is just typical proxy encryption with a single proxy. Okay? The problem of having a deployment of proxy encryption where each re-encryption key goes to a single proxy is that what happens if this proxy goes offline? Or what happens if this proxy refuses to transform the data? So we overcome these solutions by making the encryption process distribute. So basically what we have is a distributed threshold proxy encryption scheme that basically allows to split the encryption key, which I will remind you is the thing that will allow the proxies to transform data from one public key to another. So I can split this key in many pieces. Say, for example, I will split this key in 10 pieces, and I will distribute with each of these pieces to different nodes in the network, and I will require that some threshold of these nodes will have to collaborate so the receiver can get the ciphertext. So now, this implies that the receiver has to request m out of n re-encryptions to the network, and that in order to have, like a collusion of nodes, you have also to require at least m nodes, so security is improved. We support different kind of access policies, so we can support indefinite access policies, time-based. For example, nodes you can specify that re-encryption nodes only allow to share data for a period of time. You can also support re-encryption to be conditional on some payment. It can also be based on some generic smart contract logic. And that way, the nodes will apply those conditions in order to enforce the access control decision placed by the data owner. So another important aspect is that our solution is not tied to any specific blockchain. So we are basically blockchain agnostic. We can support either public blockchains, like Ethereum, for example, which is basically our main, the one that we mainly support right now, but we could also run on private permissioned blockchains. And there are many potential use cases that can be built on top of NuCypher. Basically, the typical use case will be a multi-tenant, multi-producer, multi-consumer encrypted data lake, where you have data with multiple producers, multiple consumers. It's difficult to foresee at encryption time this data is going to be shared with whom. So that's something that proxy encryption allows to do it in a really clean way. So for example, let's say some data producers are encrypting information that it's owned by some entity, would be represented by green. Then we can generate re-encryption keys to transform this data for other type of consumers that, for example, have private keys that are, for example, that are blue, right? So that way, data is never decrypted inside the data lake. It's always maintained encrypted end-to-end. We have other potential use cases. I'm not going to explain them in detail, but it can be used for making scalable and secure IoT updates. So each IoT device can get an end-to-end encrypted update of firmware or other software. Also, the generic use cases for encrypted file sharing, where you have a file owner that wants to share data with different recipients, and you have an intermediate storage layer that will, where you will put your data. Another interesting application that can be built on top of NuCypher is for multi-user chats. So instead of current solutions of secure multi-user chats, where each sender of data has to encrypt each message for each recipient. So if you have a secure Signal or WhatsApp group of 100 people, each time that you send a message, you are encrypted the message 100 times. So that's something that wouldn't be the case for a NuCypher-based application, since you will basically encrypt once and data will be re-encrypted on the server side. It can be also used to construct decentralized access control content delivery networks based on, for example, on payments, only on the event of a consumer has made some payment, then the nodes of the network will perform the encryption work. Also, of course, and the content is never decrypted in the meantime. We have already an established an amount of partnerships for applications that are built on top of NuCypher. I don't know if you can see, but most of them are on the medical and biotech data sharing part, because that's a really illustrative use case of NuCypher, where we can give back control to patients or to individuals about their data. In this case, there can be medical data, so you can basically control how your data is shared with hospitals or doctors or wherever. But there are other applications, potential applications for Internet of Things, for decentralized databases, for automobile data, or a lot of different interesting applications. So we have currently a private testnet. We are very close to having a public testnet right now, and we estimate that in the first quarter of 2019 we can have a launch of our mainnet that we intend to be public, so everyone can join and be part of the NuCypher network. And yes, you can find more information about NuCypher in our website, our white paper. All our work is on GitHub. We do open source work, so you have the GitHub repositories of our cryptographic library, and yeah, also we do all our development in the open on Discord. So if you have any questions, please feel free to join our Discord channels or write us an email, and we will be more than happy to answer. So that's it. Thank you very much. If you have any questions, I'll be happy to answer that. Okay. Yes.
So in the case of proxy re-encryption, you were saying the proxy never learns neither the private key to decrypt the data, nor has a copy of the clear text data.
Yes.
So to me, that sounds like homomorphic encryption, but you were separating those two, so I'm a bit curious about what the difference is.
Right. So homomorphic encryption can do proxy encryption, of course, because homomorphic encryption, the goal is to perform generic computations, and you could do data sharing based on homomorphic encryption, but that it's awfully inefficient. Proxy encryption is basically the right tool the right cryptographic tool for sharing encrypted data. So it sounds like it's doing some kind of homomorphic work, because the nodes are taking a ciphertext and are performing an operation on the ciphertext, and the result of that operation is another ciphertext. So it seems like it's fully homomorphic encryption or something like that, but it's actually not performing like meaningful algebraic computation, which is basically what fully homomorphic encryption achieves. It allows you to perform addition or multiplication of data, of encrypted data. Proxy encryption doesn't allow that. It just allows to take the public key, like it's not exactly like that, but basically it can be thought as taking the public key in a ciphertext and putting a different public key. So now the ciphertext can be opened by a different person, basically. But yeah, it has some similarities to fully homomorphic encryption, but yeah, it's way more efficient. So just to give you an estimation of, we can re-encrypt data in the order of 6 milliseconds, basically. So that's something that is completely reasonable. Yes.
Is there a peer-reviewed paper?
Sorry?
Is there a peer-reviewed paper about the encryption algorithm?
A peer-reviewed paper?
Yes.
Yeah, well, actually, there's not for the moment. We have been focused on the development of the cryptographic library. We had external auditors from a couple of security firms regarding the implementation, but regarding of the crypto system itself, it hasn't been peer-reviewed yet.
Okay.
Any more questions? Okay, so thank you very much.